Hello everyone, welcome to this complete crash course on design and analysis of algorithms. In this video, I will explain all important concepts by unit in simple and easy to understand way. This will help in exam and Viva interviews. So let's start with unit number 1, problem solving and arithmetic analysis. In this unit, we will understand how to approach problems, designs algorithm and analyze their efficiency. In slide number 2, problem solving approach. Before solving any problem, we follow a structured approach. First, we understand the problem clearly and identify constraints. Then, we design an algorithm, a step by step solution. After that, we analyze its efficiency using time and space complexity. Then, we implement an algorithm in a programming language. Finally, we test and validate the solution using different test cases. This approach ensures correctness and efficiency. So, what is an algorithm? An algorithm is defined as a finite sequence or well defined instruction used to solve a computational problem. It has some key characteristics. It must have a finite number, it should well defined and unbiased, it must produce correct output, and it should termination in finite time. In real life example is a recipe where ingredients are input, steps are the algorithm, and the final dish is the output. So what is algorithm analysis basics? Algorithm analysis helps us to understand how efficient is an algorithm is. There are two main factors. First one is the time complexity, which measures how much time an algorithm takes, and the second one is space complexity, which measures how much memory it uses. We do not measure actual execution time because it's depend on system configuration like processor speed and memory. So we use a machine independent approach. So in this slide, asymptotic notation. Asymptotic notation are used to describe algorithmic performance. The big O notation represent the worst case time complexity. The theta represents the average or tight bound, and the omega represent the best case time complexity. For example, in linear search, the worst case is On, and constant operation are represented as O1. Theta gives exact growth when best and worst case are similar. So we see here the growth of functions. So we can see here lots of functions. This slide shows how different times complexities grow as input size increases. So O1 is the fastest while the On grows very fast and becomes inefficient for large inputs. So we always try to design algorithmic with lower growth rate. For the case study of analysis, algorithms are analyzed in three cases. First one is best case, which is minimum time, and second one is average case, which is expected time, and the third one is worst case, which is maximum time. For example, in a linear search, best case is 0 1, which elements is found at first position, where average case is On, and the worst case is also On when the element is at the end or not present. So what is recurrence relation? A recurrence relation defined as a function in terms of smaller inputs. The general form is, we can see this the general formula, where the A is the number of subproblems and n slash b is the size of each subproblems, and the function n is the cost of dividing and combining. For example, if we consider the form, this is the commonly used in divide and conquer algorithm like merge sort. So what is master theorem? Master theorem is the use to solve recurrence relation of this form. It has three main cases. Case 1, when function grows slower. Second one, when growth is equal. And the third case is when function grows faster. If we consider the last form, it helps us quickly determine time complexity. So what is complexity classes? Now let us understand complexity classes. So first class is P class, which is polynomial time. So P class includes problem that can be solved quickly, and the second class is NP, that is non-deterministic polynomial, which includes problem that are hard to solve but easy to verify. And the third is NP hard, which is the further version of non-deterministic polynomial. It includes very difficult problem. And the fourth class is NP complete, including the harder problem in NP. Example includes sorting and searching in P class and problem like traveling salesman in NP hard class. To conclude this, the unit covered problem solving approach, algorithm design, time and space complexity, asymptotic notation, recurrence relation, and complexity classes. These concepts are very important for designing an efficient algorithms. Thanks for watching. Now let's move to unit number 2, divide and conquer and greedy strategy. In this unit, we will study two important algorithm design techniques that help solve problem efficiently. So, what is divide and conquer? Divide and conquer is a problem solving technique where we break a problem into small subproblems. First, we divide the problem into smaller parts. Then we solve each problems recursively. Finally, we combine the result to get the final solution. It also uses control abstraction, which defines the structure of the algorithm without implementation details. The main advantages is to reduce time complexity and improve efficiency. So what are the steps in divide and conquer rule? The, there are three main steps in divide and conquer rule. First one is the divide. Split the problem into smaller subproblems. Second step is conquer. Solve the subproblems recursively. And third steps is merge the solution to form the final answer. This approach is widely used in many efficient algorithms. Let's take an example of binary search. Binary search is a classical example of divide and conquer. It works on a sorted array. We repeatedly divide the array into two halves. We compare the middle elements with the target. If it matches, we return the result. Otherwise, we eliminate half of the array and continue. This makes it very efficient with time complexity of O log n. There is another example of divide and conquer algorithm, which is quicksort. First we choose a pivot element. Then we partition the array into two parts. First one is element smaller than pivot and the other array is elements larger than pivot. Then we recursively sort both parts. The time complexity is best case time complexity is O n log n and the average case is O n log n and the worst case is O in bracket n square, where pivot is selected is poor. So the large integer multiplication. This method is used for multiplying very large number efficiently. First, we divide the large number into smaller parts. Then we multiply those parts recursively. Finally, we combine the results. This approach faster than normal multiplication for very large inputs. So, what is greedy strategy? Greedy algorithm is another important strategy. It makes the best possible choice at each step. It does not go back or reconsider previous decision. This makes it fast and simple. However, it has a limitation. It does not always give the optimal solution for every problem. Here we taken the example of greedy approach. One of the common example is the Snapchat problem. In greedy approach, we select item based on profit to weight ratio. We pick the items that gives maximum profit at each step. This approach works on fractional Snapchat where we can take parts of items, but it does not work on 0-1 Snapchat where we must take the whole item or leave it. Here is another strategies, job scheduling algorithm and Dijkstra's algorithm. Here, in the job scheduling algorithm, we select jobs in a way that maximizes profit within deadlines. In Dijkstra's algorithm, we use to find the shortest path from a source node. In real life example, Google Map, which is uses short path algorithm and Dijkstra's algorithm use in it. However, Dijkstra's algorithm has a limitation. It does not work on negative edge weights. For the summary of this unit number 2 is divide and conquer is a recursive approach that breaks problem into smaller subproblems. Greedy strategy makes locally optimal choices without reconsideration. Both techniques are widely used in real applications like sorting, searching, shortest path, and optimization problems. They help reduce time complexity and improve algorithmic efficiency. Divide and conquer focus on breaking problems, while greedy focuses on making the best choice at each step. Thanks for watching. Now, let's move to the unit number 3, dynamic programming strategy. This is the one of the most important topic in design and analysis of algorithm, especially for optimization problem. So, what is dynamic programming? Dynamic programming is a technique used to solve complex problems by breaking them into smaller subproblems. We solve each subproblems and store it result in memory to avoid recomputation. This improves efficient compared to simple recursive solution. Dynamic programming is mainly used for optimization problem where we need the best possible solution. For example, Fibonacci using dynamic programming avoids repeated calculation. So what is key concept of dynamic programming? There are four key concepts of dynamic programming. First one is overlapping subproblems. The same problems are solved multiple times in recursion. Second one is optimal substructure. The optimal solution depends on optimal solution of subproblems. Third one is memorization, which is the top-down approach where we store results during recursion. And the fourth one is tabulation, which is the bottom-up approach where we build solutions step by step. These concepts makes dynamic programming efficient and powerful. So let's compare dynamic programming and greedy and recursive approach. These slides compare three approaches. Dynamic programming stores result and guaranteed optimal solution. Greedy makes locally optimal choices but may not give the best global solution. And the recursion recomputes subproblems which makes it inefficient. So, dynamic programming combines the advantages of recursion and avoids its inefficiency. Binomial coefficient. The binomial coefficient is C in bracket n slash k represents the number of way to choose k items from n items. It follows a recursive relation which is represent here. Instead of recalculating values again and again, we use a dynamic programming table to store result. For example, to calculate C in 5-2, we build the table step by step using previous values. Multi-stage graph. In a multi-stage graph, nodes are divided into stages. We find the shortest path by processing stage by stage. Dynamic programming is used to store minimum cost to reach each node. Finally, we backtrack to get the optimal path. This approach is efficient and avoids repeated calculations. Now we will see the 0-1 snapshot problem. In this 0-1 snapshot problem, we are given items with weights and profits. We need to select items to maximize profit without exceeding weight capacity. For each item, we have two choices, take it or leave it. We use a dynamic programming table where each rows represent items and columns represent weights. The final cell gives maximum profit. This problem cannot be solved using greedy approach. So we will use dynamic programming for this problem. Here is another concept, shortest path algorithm. There are two shortest path algorithms. First, Bellman-Ford algorithm and the second one is Floyd-Warshall algorithm. In the Bellman-Ford algorithm works with negative weights edges, detects negative cycles and the time complexity of Bell-Fordman is O V multiplied by E. And second, we will see that Floyd-Warshall algorithm, which is find shortest path between all pairs of vertices, uses dynamic programming, and the time complexity is O in bracket VQ. Both algorithms shows how dynamic programming is used in graph problems. These both algorithms are similar to Dijkstra's algorithm. The sum of subsets. The sum of subset problems checks whether a subset exists with a given target sum. We use dynamic programming to avoid recomputation. We create a dynamic programming table where each value states whether a sum is possible. Finally, we get a true or false value depends on whether the subset exists. So the conclusion of the and the key takeaways of the unit number 3 is dynamic programming improves efficiency by avoiding repeated calculations. It converts exponential time problem into polynomial time. It uses extra memory which creates a space time and trade-off. And it guarantees optimal solution for problem with optimal structure. The final summary of the unit number 3 is dynamic programming avoids recomputation by storing result. It optimizes resources uses using memory. It's mainly used for optimization problem and it is applied in many algorithms like Knapsack, Bellman-Ford, Floyd-Warshall and subset problems. Understanding dynamic programming help us to solve complex problem efficiently. Thanks for watching. Now, let's move to the unit number 4, backtracking and branch and bound strategies. In this unit, we will study two important problem solving techniques used for complex problems where multiple possibilities exist. These techniques help us to reduce unnecessary computation and improve efficient compared to brute force method. So, what is backtracking? Backtracking is a technique used to solve problems by trying all possible solutions in a systematic way. Instead of checking every possibility blindly, it builds the solution step by step. At each step, it checks whether the current solution is valid or not. If the solution becomes invalid, it immediately goes back to the previous step and tries the different path. This is called the backtracking. Backtracking is the commonly used in problems like puzzles, combination, and constraints, satisfaction problems such as Sudoku. So, if we go to detail in backtracking concept, the working of backtracking can be understood in three steps. First is choose. We select one possible option. Second one is to explore. We continue solving the problem recursively using that choice. Third one is unchoose. If the solution fails, we go back and try another option. This process represents using a state tree, where each node represents a possible solution. Backtracking improves efficiency compared to brute force because it eliminates invalid paths early instead of exploring everything. So we take an example of 8 queen problem. The 8 queen problem is a classical example of backtracking. The goal is to place 8 queen on a 8 by 8 chessboard such that no two queens attack each other. This means no queens should be in the same row, same column or same diagonal. We place queens one by one in safe position. If at any point the conflict occurs, we backtrack and try different position. This continue until all queens are placed correctly. This problem clearly shows how backtracking explores possibilities and eliminates invalid ones. Graph coloring and Snapchat. Backtracking is also used in graph coloring and Snapchat problem. In graph coloring, we assign color to vertices such that no two adjacent vertices have the same color. We try different color combination, backtrack when a conflicts occur. In 0-1 Snapchat problem, backtracking, we explore all possible combination of items to maximize profit. However, instead of checking all combination blindly, we prune or we can say that eliminate parts that exceed weight or not just useful. This makes the process more efficient than brute force. Now we come to branch and bound. Branch and bound is the another important technique similar to backtracking but more efficient for optimization problem. In backtracking we try all possible solution, but in branch and bound we focus only on finding the best solution. So in this case we just focusing on best solution. It uses a bounding functional to calculate an upper or lower bound for solution. If a solution cannot give a better result than the current best, it's ignored. This helps reduce unnecessary exploration and improves efficiency. Branch and bound strategies. In branch and bound, different strategies are used to explore nodes. First is FIFO, first in first out, which uses a queue and explore nodes level by level. Second one is LIFO, last in first out, which use a stack and follows depth first search. Third is least cost, which is a priority queue. Always select the most promising node based on the minimum cost. The choice of strategy affects performance and efficiency of the algorithm. Branch and bound snapshot. In branch and bound snapshot, we aim to find the maximum profit within the weight constraint. We calculate a bound for each node, which tells the maximum possible profit. If the bound is less than the current base solution, that node is ignored. This process is called pruning, or we can say that eliminating. Because of pruning, branch and bound is more efficient than backtracking in optimization problem. So branch and bound TSP, traveling salesman problem. This is the also one of the famous problem we can study. The traveling salesman problem is the another important example. The goal is to visit all cities once and return to the starting city with minimum cost. We represent distance using a cost matrix. Branch and bound calculates a lower bound for each possible path. If path cannot give better solution, it's eliminate. This significantly reduces the number of paths we need to explore. So finally, what is the key takeaways for and the summary of the final slide? Fourth unit 4. Backtracking explore all possible solutions but burns invalid paths. Branch and bound focuses on finding the optimal solution using bounds. Backtracking is mainly used for decision problems while branch and bound is used for optimization problem. Both techniques are more efficient than brute force method. These strategies are widely used in real world problems like scheduling, routing, and optimization. Understanding these techniques help us to solve complex problems efficiently in computer science. Thanks for watching.